go through just some of the technical things that make Archgard different. The one thing we do, we don't use any silicone in our systems as far as the firebox is concerned and intakes and things like that. Silicone's a bad thing, real bad thing for gas fireplaces particularly. If you go back to the days of millivolt, issues with fogging of the glass, burn them for 10 hours on high, and then clean the glass afterwards, which was pretty typical of the industry. I don't think back then we realized how much silicone affected that, and a lot of that off-gassing from the silicone is what that cloudy film was on the front of the glass. At Archgard, when I came here 13 years ago, the one thing I wanted to do was eliminate silicone. So all of our penetrations through the fireboxes, we switched over to a gasket material. Now, again, we're not hands-on, but this material here is you see it's white, and you're familiar with ceramic wool. That's what this is. Same material that we make our logs out of, same material brick panels are made out of, and those all have lifetime warranty because they're basically impervious to the fire. This is the same thing. So our entire firebox is sealed with this type material. This is a tape gasket, and so we put this gasket between all the seams, and then we rivet the system together. All of our penetrations are done with some sort of a die-cut gasket like this. Archgard used this before my time. We just expanded it to use it everywhere, and we created flanges for all of our through penetrations, or we started using them. I believe we were the first one to use these kind of flanges. And I say that because it's becoming more and more practice for companies to do it, although I do still see companies that are using silicone and just running a tube up through the bottom of the firebox and using a small dab. And I think the philosophy there is that it's only a little bit of silicone, I'm not worried about it. The reality is, if you went back to service one 5 years after it was in service, that silicone on the bottom where the pilot tube and everything came up was basically rotted out, cracked and dried and fallen apart. So I always was having to reseal that. Well, that's not a good thing in direct vent because any leakage can create an issue with flame patterns, with draft, with whatever, not to mention the potential for leakage back out. This is actually the main burner orifice mount. So we go through here, this gasket goes in, seals it off to the bottom floor, and then this goes to the valve. So our connections are basically a one-piece connection. Here at the end where it connects to the valve. Everything else in between is solid flex, stainless steel, much more durable, much less opportunity for leaks. We took that in one step further, the pilot assembly. Alright, so these are where we used to, not we, but the industry used to seal with silicone and just drill a hole in the bottom of the firebox. Alright, you see we have a flange, and again, this gasket goes in and seals down the pilot assembly. So and then this is our penetration, is here. We don't have any penetrations in our firebox that are sealed with anything other than ceramic fiber. Alright, so that's a lifetime material. I have fireboxes that I've gotten back that are 20 plus years old that still pass a leak rate test. I would actually put them on a bench and try them. And it amazed me how much stuff actually stayed sealed. Now, back then where we had silicone, I would re-silicone it. I was more testing the ceramic parts that we were using for 20 years, just to see how the ceramic held up. That and the other thing we use in our fireboxes is a little bit different type of rivet. You think, a rivet doesn't really make a difference. Well, it makes a huge difference. That's a rivet pulled, and you see how it's got a double bubble? No, see, it's called a double sealing rivet. So if I take that one and I compare it to a standard rivet, this is aluminum, but it's basically the same thing as a steel one. This type ends up loosening up over time. This is the actual, before it's actually pulled, that's the double sealing rivet, and you can see how it's designed to make a double pull and make that double bubble. There's a standard rivet, that's just a straight shaft. Alright, What this does when we do this double seal, that first bubble or that first bulge on there actually seals the hole that the rivet is penetrating, and the second one pulls it tight. So it's actually being held by filling the hole for one, and the second part is pulling it back tight. They never ever loosen up over time. Alright, much better sealing, even more so than screws. A lot of screws, you're using the hex head screws, that's pretty much an industry standard, the 1/4 inch, and you spin them. They're kind of tight, but they're not really tight. Not to mention there's potential for them to back out. This one here actually pulls it in, that double sealing rivet pulls it in and holds it, and that's permanent. It makes a big difference. Our welding only consists of the corners. We weld the corners of the fireboxes. That gives the stove rigidity, which is important. You can't, if you just rivet everything together and put this seal in, it's not 100%. If you really start banging it around, you can start moving it. We don't want it to move, so we weld the corners, bottom corners, front corners, back corners, top corners. Just a short, probably 1 inch each direction of the corners, and that makes the firebox rigid. Let's take it one step further. We have here's a traditional pilot line. This is what everybody uses, right? Just aluminum, 1/8 inch, one end to the valve, one end to the pilot assembly. Archgard, almost all of our units now, we went to this. It's a stainless steel instead of aluminum, much stronger. On the valve side, you see that fitting where it's stainless steel and brass, and that goes into an aluminum valve. Doesn't see a lot of heat there, so we're not worried about over time heating and cooling of dissimilar metals and then eventually loosening. So the other end of this, when you're doing with the aluminum, you have one end goes to the valve, the other end goes to the pilot light. The pilot sees huge temperature differences. The #1 leak in the industry, bar none, to the point of probably 80% of the gas leaks from my days of working with this aluminum were on this pilot line. And that was because you were using aluminum, and then you were using brass, and then you put it into a hardened steel pilot assembly. 3 different types of metal, 3 different expansion rates with heating and cooling, and ultimately a very likely potential for leak. We switched to the stainless steel on the hot side, goes into a stainless steel fitting, going into a hardened steel pilot. Alright, your expansion rates are very similar between the hardened steel and the stainless steel, and we lose that. Plus we can torque this to a specified torque spec with a wrench here, and our chances for leaks are probably reduced 80–90% compared to the aluminum. So that's something we do different. We could have stayed the cheaper way, which still the majority of the industry uses this for their pilot lines. And again, I think we were the first ones, because I was working specifically with Dormont for this material 10 years ago. The other thing we did, and we'll stay with millivolt even though it's a lesser part of the industry for just a second. If you see these two, these are 2 thermocouples. Basically the exact same thermocouple. You see how this one over here is shiny? That's a standard thermocouple. The one on this side here that has the kind of dull finish, it's actually an aluminized finish on top of the steel. Aluminized is basically aluminum oxide, which actually has a higher melting point than regular steel. Okay, so we've switched over from this type. It'd be probably about 6 to 8 years ago that our supplier came out with this aluminized tip. So we have less issues with the propane. So we went to this. That's standard now for us on everything we do. So there again, the Archgard difference. As far as the pilot assemblies go, us and Mendota actually are the first ones to use this shepherd hook on the electronic Okay, the shepherd's hook is basically for the rectification. We're getting more surface area and more space for the pilot to flutter, because on the single post coming up that most people use, and that single post, for obvious reasons, if it flutters one way or another, it comes off that post, and it used to be only 7/10 of a second, and it shut the system down. SIT has since gone to they have a new control module for the PF Proflane 1 or 2 that they now allow, I believe it's 4 seconds during initial startup that pilot can flutter, but if it fails it goes into a lockout. But anyway, you see the shepherd's hook, so we're getting more surface area for rectification. Gives less issues with a fluttering pilot, and it's more surface area, so as this starts to get contaminated, we have more area to actually get our DC electricity to flow through. Because understanding that rectification basically is we're flowing electricity from probe to pilot hood, and if there's any contaminant, because we're using very low amperage there, any contaminant here or here on the pilot hood actually reduces or creates resistance, and that's where you end up with failures. So, see this little tab right here? That's actually how you convert a PSE pilot assembly from natural gas to propane. So this 7/16 head here, you would actually put a 7/16 wrench, you loosen it a quarter turn, slide that over, it moves it to propane, and then snug it back up. That's all you need to do to do the pilot assembly. You see the tab sticking out? When it's on propane, it'll actually have a hole in there. If you look real close, you can kind of see writing. It does say NAT on there. If you slide that over, that is sticking out on this side, there's a hole in it when it's LP. So if you see the hole or the LP or the red dot, you know you're on propane. Now the other thing we do, and I didn't bring one with it in, you see this extra hole here? Way back when we first started doing electronic ignition, one of the biggest issues with electronic ignition is this rectification and grounding. Alright, so everybody out there was having all their issues with grounding. We actually had them put this in for us, and we actually take a ground wire from here back to all the way back to the control module, and so we end up with 3 grounds in the system. We have a household ground, we have a unit ground, or a module ground, and we have a pilot ground. So any interference, corrosion, or anything that happens on the pilot, we actually have a ground directly to it. That's an Archgard difference also. When it comes to our wiring harnesses, so you see these, and typically when you get a wiring harness from SIT or anybody else, this is what you see, right? You got a whole bunch of wires for whatever it's for. We actually have our own. We don't use SIT's wiring harnesses. We've actually upped the temperature of the wire, but the other thing we did was we have this sleeve put on there. Alright, this sleeve is actually another insulator, another form of protection, so we don't nick the wire. We protect it more from the heat, but more importantly, when we're doing that ground wire slash, back to our pilot, right? So this is our rectification wire, this is our sparker, igniter wire. When you're passing electricity through any wire, it has an electromagnetic field. If you interrupt that electromagnetic field, crossing, every time you cross a wire like that, you basically create interference, even though there's an insulation jacket around it. Alright? The smaller the amperage, the smaller the voltage, the smaller that electromagnetic field. Okay, when it crosses, in effect, we're actually reducing our voltage. So, rectification being a problem, especially when you're using longer rectification. The more you cross these 2 wires, the less that voltage is, and it's affecting your ability to do rectification. Way back when we first started, and again, knowing what the furnace industry went through, and knowing what the all the other competition we're going through, we started putting on more of this insulation jacket. And you see this is shinier than this one. This one here is a protector. This one actually becomes an insulator. And so we run that wire through here. So all of ours, we do put these sleeves on in-house. So our rectification wire and our igniter wire get covered in this. Alright, so what this does is actually whenever these cross each other or any other wire, it creates space for one. Plus it's a second layer of insulation jacket because this one's kind of like dipped in a silicone type material. We created that space and we insulated and protecting that electromagnetic field. Not to mention it still protects it from rubbing or nicking. And you know, this wire here, the electrode for the sparker, for the igniter, if it gets a little nick in it, because you're dealing with high voltage, low amperage, a little nick can cause, in the right spot, can cause it to actually jump through the insulation to a piece of metal on a firebox instead of it all coming up to the spark, the igniter, which ends up giving you a cold spark and your fire doesn't light. So this is again an Archgard difference. This here, this is a standard SIT valve, 885. Same one everybody uses. It's just the only difference from ours to theirs is depending on what your turn down rate is and what your steps for the motor are. There's 3, 4, 5 different variations, and that's just pressure. Otherwise the valve is identical. Now you see this tower, this little tab here that holds these wires on is exposed, and quite often this ends up getting knocked off. It's basically glued onto this tower. They're real fine wires, and we were having issues with them getting knocked off, both here while we were manufacturing and out in the field. And of course then you have to replace the tower, and you know, you installers, you need to be more careful. But we were seeing enough. We kept going back to SIT, and SIT kept saying, oh, you know, your guys are being too rough, tell them to be more careful, yada, yada, yada. I'm a former installer serviceman, so that wasn't a good enough answer for me. Because I believe in making installer serviceman's life more easier. Alright, so this is what we did. You see that? That's the tower. So if we look at the two towers side by side, you see the difference. We actually went and put a double thickness shrink wrap on here, and we've now locked that all in. As far as I know, we're still the only ones doing that. It's extra time, but we want to make sure that they're not having to go back. So they called us, said they're having a problem with this. We said, here you go, here's your fix. We've been doing this for probably 4 or 5 years now. So anyway, that's another thing that we do different. Control modules. You know, it's, again, there's a couple variations of it from SIT. One thing we do is we take the information, there's all your information on the back. We take the pertinent information, date code, version, and part number from the back and put it on the front. So when an installer goes out in the field, let's say there's some, let's say there might be a recall in the future, or when they went from Rev 3 to Rev 7 to Rev whatever, they, we know what's in there. So we can say, hey, at Rev 3, since then, on the jump to Rev 4, they move the voltage up. Tell me what Rev do you have. It's on the top instead of having to take this out to get at the bottom. This one here, this is our new control board. And I say our, again, Yodel and Archgard went together and we developed this particular control module specific for us. The two of us combined, Archgard by itself, Yodel by itself, were not big enough to get SIT to listen to us. By partnering up, we were enough volume for them to listen and create this module for us. So, what is different about this module? The original control module, what would happen is you would start, you'd get the signal and it always starts on high, and then it goes to whatever setting after a couple of settings. So if you were on high all the time and you had a cold chimney with no draft, you get that blue ghosty goes out or shuts off, clicks the pilot, starts it back up, restarts the system, goes blue, goes ghosty, shuts back up, does that 3 times. Then it goes for a minute with just the pilot running, trying to establish draft. All right, and it'll do that 3 times before it locks out. And we said, well, guys, you know, the real issue is we're putting too much gas into the firebox before it's ready to take it. So what we had them do is they now take with this control module with our new one, which is identified with a different part number in the back. What happens is we actually light on low. So effectively we're putting 50%, 30% or 50% less gas into the firebox. So we need 30 to 50% less oxygen. And so it's able to overcome the draft issue quicker. We get the system working. It runs for 2 minutes on low. After the 2 minutes, it will then go to whatever setting the homeowner has, whether it wanted it on high, on low, on medium. Wherever they had the remote control set, that's where it will go. And our theory behind that too is that the homeowner will never know. The first 2 minutes of the fire, I'm sorry, they'll know it's on low, but the first 2 minutes of fire is always blue and ugly anyway. So during this time, let's, instead of taxing the system and making it suffer and try to make its way through it, let's actually go and put it on low. Let it burn for 2 minutes on low, really establish a nice draft, and then let's go to the higher setting, and away we go. Alright, so that's how we do startup. Significantly reduce problem ones, because no homeowner, when you tell them that says, hey, that's normal for it to try to start, stop, start, stop, start, stop, run a pilot for a minute and go. I wasn't okay with telling customers that. And we actually didn't, I won't say we had none or zero, but most of our product, most of the time, worked from a cold start. But that one occasion here and there, it made sense to do this. So we ended up doing this and partnering, like I said, with Yodel. So we can't keep that exclusive. SIT won't do it. We're high enough volume for them to listen and make a box, but their thought process was, once people start seeing this, they're going to want this, and we don't want to lock it down to 2 of our smaller customers. So, and I could not promise them, nor was I willing to pay extra to keep it exclusive to Archgard. So eventually you'll probably see this start showing up in other fireboxes.